Hello and welcome everybody. I'm Jess Berg and I'm the current chair of the Pacific Northwest AES section. I want to share that I'm based in Minneapolis and acknowledge there's a lot going on in the world. And I'm so grateful that we can gather in this way to be in community with each other and our shared love of audio. This is our section's sixth official meeting of the year, and we are so glad that you're here. We had a hybrid meeting in January at DigiPen Institute of Technology in Redmond, Washington, titled Audio Signals versus the Ear: Time, Frequency, and Bandwidth Revisited, presented by James J.J. Johnston. Thanks again to JJ for producing and hosting, to our treasurer, Lawrence Schwedler, for coordinating with DigiPen, and to Dan Mortensen and team for the technical support, our section secretary, Gary Louie, and our webmaster, Matthew Sutton. It was a very special evening for all who attended. A reminder that our section's meetings are typically September through June and will either be hybrid or fully online so people can join and participate with us from wherever they are. Our next section meeting is being planned for March, time and date to be determined. Details to follow soon. The subject will be on open sound control, produced and hosted by Michael Ashton. And is Michael here yet, Dan? Do you see him on the list?
Seen him, no.
Okay. Michael should be joining us then at the second portion, and I'll have him share a bit more at that time. So stay tuned to the latest on our webpage, where you can also learn about becoming an AES member. There is a blue button at the bottom of the page that says Joining Info. You'll need references, and any of our sections committee members are happy to be your reference. Just ask. It is very important to our section that our meetings remain free and open to all. We use Zephy instead of Eventbrite because they don't take any fees. 106 people registered for today's meeting from all over the United States and the world. Donations totaled $85, which is very generous. For us, this covers all of our committee business needs, and we thank you. Today's meeting will begin with a tour and includes a brief intermission before the main presentation. We will leave the Zoom room open at the end of the meeting for anyone who wants to stick around for an after show hang and chat more about whatever audio topic you want. A friendly housekeeping reminder: we kindly ask everyone in Zoom to please use your real name first and last. Please reach out in the chat if you can't find where to do this, and we can assist you. Also, please be mindful of muting your microphone when not speaking. Please keep your microphone muted and your camera off during the main presentation as well. For Q&A, online folks, feel free to utilize the chat to drop questions in along the way, and I'll address as we can. In-person folks will have an audience mic to speak so everyone in Zoom can hear. We will pause along the way for questions. So we thank you for that. And I think this covers the business portion. So let's get to the fun stuff. We are very excited for tonight's presentation produced by our Pacific Northwest Committee member, Luke Goodloomis. And I will now toss it over to Luke. Thank you.
Thank you so much. I appreciate that. Thank you, everyone who was able to make it here in person. Thank you to everyone online, whether it be afternoon, evening, morning, depending on where you are in the world. I think we have a pretty exciting presentation. We're going to, well, first we are here at Biamp, which is in Beaverton, Oregon. This is their kind of world headquarters. So they have design and manufacturing here, as well as some test facilities that we are going to take a tour of here before the formal kind of presentation starts. The formal presentation will be on this very cool, probably one of the coolest guts of a loudspeaker I've ever seen, if not the coolest. We could just say it. It's the coolest. It does things that other loudspeakers only dream of doing. And there's some patents behind it. It is unique, one of a kind. And I thought interesting enough, both performance, real world applications, applicability, as well as on the science and the design and the research behind it to bring it to the AES. So thank you for joining. And if there are questions here in person, I think we can do a dynamic kind of Q&A during, if you know, raise your hand or shout it out. We will run to you. I will run to you with a microphone so that people online can still hear you. But don't be shy if you know things show up. So with that, Denny, do you want to say anything before we head out to the tour?
Welcome and enjoy yourselves, because this is an adventure that I am personally very passionate about, and I welcome you into our world of the science behind something quite extraordinary.
All right. So with that, I'm going to put the microphone on the stand, grab an iPad, and we are going to have a mobile tour. So those online will be able to join us as we get a tour of an anechoic chamber, some test facilities, and then a quick kind of wrap around some of the greater product offerings that Biamp has. All right, here we go.
And I might add that Luke is very talented, and in this case, he's going to be the cameraman for the tour. He's ready to jump in any capacity to make things happen.
Good.
All right.
Okay.
So we'd invite all of you to join. Hi, Eric. Welcome. Thanks. There's other people here that I haven't met yet. Sorry I didn't call you out by name, but if you'd like to join Luke, we're going to take you into the room next door, affectionately known as the Bat Cave. Bat stands for Biamp Audio Test Facility.
Luke, we're not hearing your camera.
Oh.
Yeah, it's because he's still in the room. As soon as he gets
Here.
out of the room,
We'll leave we'll get out of the room here.
yeah.
And-
Welcome.
All right, mic's on.
This way. So, we have the perfect number for, you know, a room that isn't huge, right?
All right, all right.
I mean, it seems to have some acoustic treatment that takes up a lot of room. So here we go.
I'll follow you in, please.
All right, all right.
And just to prove that we're in the right place, well, our cameraman is taking up the loose end here. Let everybody gather in here first. Well, just to prove we found the right place, Luke is going to focus on the wall here. It's indeed what I said it was. This is a fine gentleman that I'm happy to say shares my passion for live audio. He's got a background in that. He's Nick Brisbois, and he is the overseer of all the excellence that happens in this end of the building. And I'm going to turn it over to you, sir.
Great. So today we're getting a tour of what we call the Bat Cave. It's the Biamp Audio Test Center. Biamp Audio Tests Certification and Validation Enclosures was the acronym that we came up with. We have an anechoic chamber and we have a reverb room in here. It allows us to test for UC certification compliance. So looking at products that are going to go out on the market for use with Teams or Zoom, Google Meet, different UC categories like that. So we test our speakers and mics for those applications. I'll ask you to leave drinks on the table out here, please. Just on the off chance that something got dropped in the anechoic, it's a nightmare to clean. So, and then we can come on up the stairs. You can go ahead first.
Okay.
Please watch out for any cables on the floor. You don't want to step on those. The floor will cut through them. Yeah, watch your step with any cables that are against the edges there. People always like to huddle against the walls, and that's right where the cables run. So we've had this chamber for a couple of years now. We have a couple of products in here to be looked at right now. The test equipment generally in the anechoic, we have a sound source, which is an artificial mouth and a measurement microphone. And then the devices that we're testing will have a microphone and a loudspeaker, so we can put devices into a test call and hear both ends and capture the metrics of what's happening with it. So right now we've got one of our ceiling microphones and a ceiling speaker. And because the chamber has no audio reflections, we don't need to put it on the ceiling to test it. We can invert it and just test it on the floor, which is a lot easier. The room itself, we're about 14.5 feet by 13.5 by 9 feet tip to tip on the wedges. The exterior dimensions are about 5.5 feet greater in each size. So 20 by 19 by what, 14.
14 by 13.
14.5 by 13.5 internal,
Okay.
by 9 internal.
By 9 up.
Yeah. So underneath the fiberglass grid is the mirror of the ceiling above us.
Okay.
So it's all wedges
Yeah.
tucked down below us there. It's hard to illuminate them and actually see them. So you can kind of peek through and see there's a scrim under there in case you drop your keys that they don't vanish down 3 feet to the floor.
Yeah, I see the wedges
But
down
you
there.
can see the tips of the wedges a little bit if you're
screen.
getting the right angle on the lights.
What's the depth
So-
of the absorption behind the wedges?
The wedges on the wall, you can see them here on the door. They're about 19 inches deep.
Right.
So we've got a 19-inch wedge, and it stands out from the wall about 6 inches.
Okay.
And then the wall itself is a perforated steel. It's got another 7 inches of insulation in there. It's a recycled denim. It's this stuff here.
Oh, yeah.
Filling that, and then it's got an inch of drywall on the outside, and then 16 gauge steel behind that. And so the walls are actually part of the absorptive material. So we looked at a couple of manufacturers. A lot of them will do the wall, and then the wall is a solid barrier, and then they do everything with the wedges on the inside.
Right.
And so we could get a larger chamber. This is ETS Lindgren's chamber. And so, we also like the melamine foam rather than the fiberglass. Just, you don't get that much fiberglass dust from the chambers with the fiberglass bat in kind of the chicken wire, but this just seemed over time like it would be a nicer working environment. So we've had this for a couple of years now. It's been very, very useful to us. It allows us to get our products in here. We can test them and kind of go through pre-certification. Heather, watch out for cables on the floor when you walk around. So it allows us to test hardware, basically for all the UC vendors. They have their certified laboratories that they do final compliance testing with. But we want to be as close to passing when we get there as we can be. Before we had a on-site chamber, we would send our gear out to off-site chambers, and it just is much faster, much more efficient to go through it. Being able to test here, we've got our DSP engineers just down the other side of the building. So when we want to, we have questions, we want to talk about a product, we just walk right over, grab the person of interest. They come over, they listen to it in real time and say, oh yeah, I see the problem, and we can tweak something. So it just is, a much more efficient use of space. This lab is dedicated. Oh, go ahead.
I'm just curious, what's the noise floor in here? Have you measured?
It varies. We see the variation happens down kind of below 30 hertz. You get kind of 20 to 30 hertz noise from motors on pumps locally, but in the 15 hertz or 15 dB range.
Oh,
Yeah. So very quiet. Now watch out for cables on the floor, please. And so, yeah, it's a very quiet environment. I was watching a video the other night, and they were showing a tour of a chamber, and they're like, this is a anechoic room. It's inside of a concrete shell built inside of another concrete shell. it's like the noise floor in there has got to be just,
No.
unmeasurable. But for our purposes, it is an expense we don't need. None of our products are living in a world where it's as quiet as 15 dB to start with. So that's perfectly acceptable for us. If we were doing military grade, space applications type stuff, I'm sure there's an application where we would need that.
I would suspect that if you were doing instrumentation microphones, you would need all the way down to zero.
Yeah, yeah. But we're not building the test microphones ourselves, so we don't need to be that low. And so this one is really dedicated for UC applications, so communication applications, telephony basically is what we're doing. And then on the East Coast, we've got the guys who are developing our speakers for community and stuff. And so Charlie, who will be talking later tonight, is based out there. And so he can talk about their test environments and things too. So it's been a real boon to have this, and it's pretty great. Yeah, it's anechoic down to 100 hertz is what we tested it to. When they were certifying it, the guy who was doing the certification was like, "Oh, I wish I had the larger dodecahedron because we could probably get it down. We can definitely go below 100. We don't know how low." So he thought, we probably 85, 88, somewhere in there. But 100 for our purposes is fantastic. It was lower than we expect. So it all worked out great. Any questions on the anechoic room?
You got a ceiling speaker. This is the ceiling microphone.
Ceiling tile microphone, yeah. So that one's
an array, a phased array or something.
Yeah.
Okay.
Mm-hmm. Yeah. So a load of MEMS speakers, and then it does up to 12 beams out of it. So it can be set up to different configurations. That one is from Clear One. We just acquired them recently. So looking at their hardware and incorporating that into our line.
Yeah. And the treasure trove of IP that goes with it.
Yeah.
Yeah.
Yeah. So we're learning as we go, and
You see the measurement microphone over there, but not right here.
yeah, yeah, that one's a Grouse 3-field mic.
Okay. Grass. Okay. Not
What test equipment are you using with this?
We use head acoustics, which for Teams and Zoom, that's kind of their preferred platform.
Okay.
We looked at a couple of others, and then as we were building this room, Microsoft said, "No, we're going to standardize on head acoustics." And it's like, okay, that's our decision made then.
So that's for teleconferencing, that's the standard?
Yeah.
Okay.
Yeah, there are others that are used for other applications, but for our purposes, that was the one. It was really driven by, the product that we're trying to certify. Yeah. So trying to recall the name of the other. Totally blanking on it at the moment, but there was one other that was definitely a strong contender that we were looking at, and then once they said, "Oh, we're going to standardize our requirements on the head acoustics package," then it was, that fell by the
I'm
wayside.
kind of aware that Neumann Sennheiser has something of that sort.
Yeah, there are many. Shure's got one, Sennheiser's got one. There are numerous out there. Sony has one.
Okay.
Yeah, it's a popular format. So, and people like it. It just effectively vanishes into the ceiling. We've got some others next door we can show off. We have a small form beam forming or beam tracking microphone that honestly the range is, we've put them up against the Shure, against the Sennheiser, and in terms of coverage distance, they're all basically equivalent. With any microphone, the pattern kind of dictates the distance that you're going to be able to get from that microphone, and beyond that, you get into the noise floor of the room and you get drowned out by the noise floor.
The application goes beyond audio too. You use it for camera automation.
Yeah.
In other words, the camera points wherever the sound is coming from.
Essentially, yeah. Because, imagine you've got facial recognition on your camera and you can see that there are, 8 people in the room. but somebody might be chewing gum and another person's yawning and a third person is talking. Well, which one should it zoom in on? So we use the audio as a key to pull the right preset. And then from there, we can let the facial recognition, keep the tracking going. But we need to figure out who the talker is first and then move from there. Yeah. And you can see I've got this kind of material up against the mic. It's really just to prevent any stray reflections or try to minimize stray reflections. It's to what degree it's required is questionable.
I'm curious about the sound source there. But
Yeah, it's basically, you'll see the head and torso type simulators. It's the same sort of a voice box as those. It's I think a 3/4 inch throat, and it's mimicking human speech.
This one's passive.
Yeah.
Okay, so you're driving it with an app. Yeah. Okay.
Yes. Yeah.
They do make an active version of that.
Mhm. Yeah. And then we've also got like the NTI talk boxes and things like that you'll see those out in the hall, various things. We've got a couple of the head and torso devices. One of those is out for certification this week. The other one's in the lab next door. Yeah.
Okay.
Any other questions regarding the anechoic?
Any questions from our Zoom room?
Yeah, if
I'm
you
not-
guys are quiet for a few seconds, can you hear your hearts beat?
No.
Somebody check my pulse.
Yeah, I'm
you.
more aware if you're in here for a while, you notice the blood rushing in your ears a little bit once in a while, or if you're chewing gum or something like that, you'll notice like kind of that bone transmission stuff going on. But yeah, your actual heart beating, I haven't been aware of.
Considering what the background noise I hear in my own shop, it's gone.
Yeah.
It's gone. Okay.
Yeah, I liken the sensation when you come in here. It's when you're a little kid and you're playing hide and seek, and you hide in the closet with all the coats, and you're just in that totally enclosed, deadened environment. It's sort of the same feeling that you get when you come in here.
Yeah, the only other place I've ever been that's approaches this, University of Chicago has a cinema screening room with an NC-10 rating,
Oh wow!
and it's not anechoic, but if you're in there alone, you can hear the blood rushing in your neck.
Yeah, that's wild.
Yeah, it's something.
Yeah, one of the interesting things in researching anechoic rooms and learning about them, the size of the room. Once you've got, like these baffles or wedges are 400 hertz and up. If you were to scale the room up, the wedges don't get bigger. Those are frequency dependent. So if you were going to say, oh, we want to go down to 50 hertz, well, now you need wedges twice as big. But in terms of maintaining 100 hertz for the room could scale up to 40 by 40 or something, and the wedges would stay the same size. You would just have a lot more.
That's why I was curious about the walls,
Mhm.
but whether that was a gain on frequency or STC or a balance between the two.
Yeah, it's a balance
Yeah.
of both. I think the exterior with the steel and the sheetrock really gets you the STC.
Mhm.
The what do they call the stuff? The insulation fill definitely deadens it too. This I don't think really does much for you in terms of STC, but the whole idea with this is as the sound energy is going in between the wedges, that it can't bounce back out.
Yeah.
You don't have a flat surface for it to echo back out at you. So you've got a porous membrane that it allows it to go into, and then it gets trapped in there.
So I'm thinking an ordinary room, the big reflectors are the corners
Mhm.
too. So, and that everything that goes into them comes right back to where it started,
Yeah,
like my voice.
right. Because you've got that
Yeah.
that 90-degree corner, and so you've got
90, 90,
45,
90,
45
90,
and back
yeah.
out, and so you can make a box coming right out of it.
Yeah.
And with the angle on these, it just keeps going in.
Cool.
Is it an option for Biamp employees or executives to come in here to get the heck away from everybody?
I often joke we should set up some hammocks in here, or a couple of lounge chairs, and just you rent it by the hour for the day. Yeah,
Thank you.
you're welcome.
Maybe Steelcase will come out with a version.
Yeah. Cool. Okay, we can keep moving. All right, our next stop is going to be down the stairs and to the left.
I noticed the turntable.
So this room is, we can go ahead and move on in. Atmos room. No, it's basically a conference room. So in the anechoic, we get the isolation, so we can test the device and only the device. In here, we want to know about the interaction of the device with the room. And so it's meant to be just an average conference room. And so it's got sort of average conference room dimensions. We don't want it to have a horrible RT60. We don't want it to have a great RT60. It's supposed to be just sort of average. And so we shoot for somewhere in the 400, 600 range for RT60 in the room. So that we know that when we're trying to tune our products, we've got a sound bar in here, we've got ceiling microphones and speakers. When we're trying to tune the echo cancellation, that we're dealing with a normal kind of liveness of a room. We designed this room, we put French cleats on the walls so we can hang material on the walls at different heights. We've got an installation panel back there. We've got a plexiglass panel on the wall up here. We can, to some extent, vary the reflectivity of the room and the absorption of the room to make it better or worse as we're testing products. So if we want to try to make the reflections worse, you have a conference room that has glass panels on the walls, a lot of windows. We can try to emulate that to at least make it more of a torture test.
And I hear you're playing these ambient noise.
Yeah. Right now we have 8 speakers around the corners, and they're kind of just doing a cafeteria noise. That'll be part of some of the tests. Is how do you react to that background noise and isolating them from the voice? So this room is in different configurations, is used for. We've got some of our ceiling mics up here kind of permanently installed so we can move around just by plugging them in and out, and ceiling speakers as well. We've got 3 different models set up in pairs. We've got that same microphone we saw in the other room, the panel microphone. We've got 3 of our TCMX beam tracking microphones and a TCM1 beam tracking microphone. So
Do you ever hang glass off the French cleats to do the architect-y full glass wall, 2 glass walls kind of conference rooms?
I haven't gotten, I have, I think, 5 panels that are sort of a 4x6-ish size.
Okay.
And so we've put 2 on each wall there and then 1 on the end wall to try to get it as live as possible. I don't have enough material to cover the entire room floor to ceiling. And the expense of doing that is, at that point, it's let's go out and rent a room because it'll be cheaper.
Sure. So the anechoic was NC15. What would this be?
This is actually not much worse than that. When you seal it up, it's a STC rated door.
Okay.
And so the lab space, the exterior part of the lab is fairly quiet to begin with. It's isolated from the building. So in here, we're like 19. It's remarkably close to next door.
Okay.
Yeah. It's double wall, staggered stud construction with polyfill or with insulation and rock wool insulation in the walls. So, we do have a fair amount of isolation in here. And it's quiet rock on the outside.
Steel versus wood, I've heard that story, but.
These are steel stud, staggered. But it's standard sheet rock on the inside, quiet rock on the outside. And then the rock wall fill. So it's got good insulation. We have next door to us, we've got sort of our machine shop area. They don't do a lot of heavy work over there, but every once in a while there's really they're banging on something. And if I'm doing tests in here, I'll isolate the mics and listen on headphones, and it doesn't bleed through. So it's really good. Yeah. So this is one of the head and torso tech devices that we use. So it's got a mouth for speaking. It's got ears with mics in them, and depending on what the application is, this one's just kind of a generic ear, robot ear shape. And then you've got the more realistic ear on this side. The more realistic ones are becoming the standard for all testing at this point. They started out, from what I understand of it, really for cell phones and over the ear headphones to make sure you were getting the performance you thought you were getting. Prior to that, they just did kind of a generic ear for telephony stuff. So like that's, we're at a distance from, well, not so much from a handset, but from a desk phone or something like that. They didn't care so much, I think. So I'm not an expert on the history of these guys, but that's kind of what I've gleaned from reading. But it's a silicone insert on both sides and then a microphone behind it. It's built into the head. So for calibration purposes, when you need to put a piston phone up against it, you have to unscrew the ear, that comes out, and then you've got access to where the actual mic is. Right. Yeah.
How do you use the taped angles on the floor?
Oh, these were, so our sound bar here, they have a camera embedded in them. And so we were doing, and they're also a beam tracking microphone array. So we want to make sure that when we think it's pointing at the talker over here, that it actually is. And so we can query the bar, see what the angle that it reports that it's pointing the microphone array to be at, make sure it's aligning with where we think it is. And then the tape on the floor gives us reference for the camera point of view to say, okay, if I put this artificial head out at the end of the line at 45 degrees, that's my reference line to find where that head ought to go. So we can say, okay, put it at 60, put it at 45, at 30. And then we can verify that the microphone is actually pointing that orientation. We don't want it to say, oh, it's pointing at, plus 45 over here and the head's at minus 45 over there.
So using the head as a source.
Yeah.
Okay, got it. Thank you. That's cool.
Yeah. Yeah. Any other questions about the room purposes?
It's really
Cool.
It's really interesting in Zoom that we can hear the difference clearly between these two rooms.
Yeah. Yeah, I expect so. It's not, you come into the room and it's not overly reverberant sound, like you filter it out pretty quickly. That's one thing you learn when you're working with microphones is the things that you naturally filter out when you're in the space, the microphone doesn't naturally filter out for you, and the far end isn't in the space physically, and so it's much more noticeable to them, the reverberance of the room, because you don't have the spatial cues to know that, oh, I'm in a room this big and it should just sound like that.
Right.
Yeah.
That seems like an important lesson
Yeah. It's
to keep in mind.
It's one of the reasons the products are getting deverb put in them now, to minimize that, so the people listening on their headphones, it just sounds like somebody sitting in, talking on a little mouthpiece instead of sitting in a big echoey room.
Deverb is a product?
Yeah. Yeah.
Are we going to hear about that later?
We have it. It's incorporated into a bunch of different UC platforms, but yeah, it's basically a de-reverberation algorithm that keeps the voice and tries to strip away the echo.
Huh.
I would say from my own experience in this regard, it's better to record in a so-called dry environment or non-reverberating environment. And I hate to use that word dry because people tell me that if the humidity goes up in a room, the reverb goes down, which is the opposite of the so-called wet dry psychology. But I know that if you're recording in a room that is too reverberant, it's hell to get rid of it.
Yeah.
So
Yeah.
add it later.
Yeah, it's hard to take away. Hard to take away and leave the source sounding good.
Yeah.
And that deverb isn't in a speaker that you put in a room to get rid of the reverb.
No, that's.
Can you work on that, please?
Would love to. Love to. If we can patent that, and we'll be ahead of the game. You bet. Yeah. Yeah.
Thank you.
All right. We'll,
They can sort of do that with headphones though, can't they? Get rid of the background noise.
yeah.
Noise canceling headphones, so
Yeah, but once you introduce energy into the space, it's
that's another story.
like you basically, yeah, it's really tricky because the room wants to resonate at the frequencies it wants to resonate in. And you can do what you can, just like the feedback to reduce those frequencies and try not to excite it, but there's only so much you can do. And for the people in the room, you can't stop them from doing those.
I would imagine the deverb is 3 different processes then. You're getting rid of the modes, any standing wave energy that's being picked up. You've got to deal with the first reflections, which is probably the least of your problems, and then processing and working out the diffuse field
Yeah,
tail.
that's an area that I don't have any expertise in how they write the algorithms or do the algorithms for the device.
Well, I could imagine wall-to-wall, ceiling to floors, loudspeakers and microphones that would reach out and cancel out everything. But-
Yeah.
Maybe just describing my installation.
Your price point goes up.
Yeah, definitely. So,
Acoustic treatment's even cheaper, actually.
yeah.
Sometimes.
Same some drapes.
It's architectural consternation too.
Cool. All right. Well, we'll keep moving on.
Yeah, any other questions from the Zoom folks? I'm not seeing anything in the chat. Just a comment from Stephen DeVore said Deverb, I think, was an old TDM Pro Tools app.
They may have had something of the same name.
Yeah.
But
that's it.
Biamp's application is extraordinarily different than that plugin, though.
Okay.
Can you
I
guys
see.
can you guys hear me?
Yeah. Hey, Joe. Go for
Oh,
it.
hi. Hi there. Yeah, sorry, I don't know if I interrupted somebody or not, but I was just curious again, who is it that makes that that artificial head?
This one is one of the head acoustics ones here. There are a couple of manufacturers who make them.
Yeah, but that's Head Acoustics, right?
Mhm.
By Professor Genuit, I think it used to be, if I remember correctly. That the first Head Acoustics ones that came out that had a whole torso and everything.
Mhm. Yeah, and we've got a torso box for it for automotive applications more, or you can sit it at a table and it'll be at the right height. But it, the box has got little strap points for being able to seat belt it into a car so they can test it during driving. Again, some of the applications are more cell phone specific, or, we do conference rooms. So we're not really, there are some jigs that come for the heads that bolt on to some mounting points in the back that'll fix a cell phone, and to articulate it and move it and certain, you can get it really precisely calibrated position for the headpiece, distance to the ear, distance to the mouth, all of that sort of thing.
Thank you. Oh, now we're getting to see a real ear, or the real ear.
A real synthetic ear.
Yeah. Wow. Okay.
No accessories, though.
Thanks. Any other Zoom room questions?
Is it? Oh, is it? I just tuned in just as you were exiting the anechoic chamber, so I didn't get to see any of that. This will be posted, I assume, at some point on the website.
Yes. Yep. We're recording.
Yeah. How long does it take to get it posted?
Just depends on how much time we have for post-production, but we'll keep you posted, Joe. Thank you.
Thank you.
Yeah.
Cool.
All right.
All right.
Excellent.
Moving on back to
Yeah.
the other room.
Yeah. So we'll exit this space, Jeff, and pause right here, right outside the door. And we're gonna have another quick little demo of some of these things out here.
Looks like there's a nice food demo over there on the right.
Is this everybody? I think so. All right, Chris.
Well, hello, my name is Chris Bailey. I'm one of the senior applications engineers with Biamp. So here in Beaverton, we support our products of customers and also support development of products. And this area is actually a validation and or development test space for a new take on an old voice lift technology. So we're using our parlay array microphones and the ceiling here to demonstrate voice lift within our system end to end from microphone to loudspeaker. And it's probably hard to see from the iPad, but here's a upside down view of the grid, kind of an RCP view of the distribution, but it is a grid of microphones, 10 microphones, 12 loudspeakers. But we are doing mix minus gain shading from microphones to the respective loudspeakers. And I guess if we wanted to demonstrate it, it'll be hard to pick up on the Zoom call, but for those of you in the space, you can actually walk around here. My teammates Carl and Scott are down in the far end, over 40 foot away. So, hey guys.
Hey Chris, how you doing? How does it sound over there?
Pretty well, I can hear you over here. So
It came through remarkably well.
kind of hard to capture on the video without being present here. And even when you're here, it's more omnipresent than it is directional. So that's something that's hard to capture. So I think at this point, if there aren't any questions about this quick little snippet, I'll hand it off to Scott. And
One question.
Yes.
So those ceiling squares are a mixture of speakers and microphones?
Yes. So the ceiling clouds, if you will, is kind of a broken cloud layout. And there's a microphone followed by a loudspeaker followed by a microphone in an alternating pattern. And I can show the floor sketch. That is the microphone there, and you can actually see the red indication on the LED there is actually tracking to my voice as I walk around. It's a bicolor LED array, so we have to alternate red and green for the different beams. Each one of these arrays has 16 MEMS capsules and forms with mathematics, virtual beams that are cardioid patterns, and we indicate azimuth fitting of each of those beams with LED. Does that answer your question and then some?
It does. And then each microphone is going to the far or to some combination of speakers. Probably not so much to the near one and a lot more to the far one. And it can tell where it is.
Correct. We actually, Carl on the far end there has developed a quite involved spreadsheet working with inverse square law to calculate what those gain shading cross points should actually be. Did I get that right, Carl?
Yeah, that's exactly right. So it's basically proportional to it's the inverse square law relationship to distance, and that's
That's the method of calculating. If a loudspeaker is close to the mic, we don't send anything to it. And then, but as it goes further out, we use inverse square law calculation to determine that weighting, that gain matrix through the room. And
Are there any,
far
are there
end,
any,
all the mics are mixed together, separate signal path going to the far end.
are there delays in there, or is it just gain shading?
We've tested both, and the average user doesn't actually perceive the difference. So depending on the end user, we can tailor a little bit more. We have had some very opinionated and rightfully opinionated individuals discuss the cognitive dissonance that so we've definitely debated and considered. We've run those calculations as well and can implement them, but the return on that investment is seldom noticed by the average user. So
for rooms that are about this size and smaller, the intrinsic latency of the system is about such that there's not much benefit except for maybe the very most extreme combinations, and the misalignment in that situation is not much.
yeah,
Thank you.
system latency is in the neighborhood of 28 to 36, depending on the design. So that actually kind of works out to align with the time arrival coincident. So
I noticed the background noise in the room, and it's still coming through intelligently, but I assume from fans and things, and even maybe the HVAC, I don't know how much, which is what, but
yeah, we do have like this entire demo space, which is our sound masking solutions and all of that. So it's not the most challenging voice lift situation that you can go into. Incidentally, that's like the signal path that's running the voice lift system. If you see, so when I'm kind of talking, there are like the mic GUIs lighting up. This should be interesting. And if you see, there is like a meter on the right side, which shows how the gain shading is working. So because I am near one of the mics on the end of the room, you can see most of the signal level going to the other loudspeakers, which is on the farther side. Okay.
Zoom is really taking care of the fan noise. We hear nothing of that, and it's remarkable how much Carl sounded like he was standing next to us from that far away. Over Zoom.
Could someone
That was amazing.
Start here and then talk as you walk all the way across, and we can.
Touch anything there, but walking under this line microphones, walk and turn around, talk at this point, and I'm right underneath this microphone with a beam pointing at me. But as I face the other direction, it's just, I think one of our clients' biggest requests is we want to have flexible furniture in a flexible space and have pickup no matter how I arrange the furniture.
now, as you stood just in that area, I started to hear a trace of squeal coming through.
It's possible.
Okay.
For the benefit of those on the Zoom, how far away is our esteemed speaker at this moment in time?
30 feet?
The talker?
Yes.
35 to 45 feet, maybe?
Yeah, about 50 feet.
50 feet?
Shows the distance.
Yeah, so from wall to the other side, it's like 60 feet from here to there. It's about 60 feet.
Yeah, 60 feet.
Huh.
At this point, I'm probably 8 to 10 off of the microphone. So
if you want to get like more of it, it's like you might want to stand near under the loudspeaker.
We'll go under the loudspeaker. So here we are, Zoom folks. Now we're actually under the loudspeaker. We were about 8 feet out of the direct path of the loudspeaker.
So in this position, I'm about 8 foot from the nearest microphone. Oh, there's still some left. Styles are at about 8 foot, so we can. Well, there's the constant where the lower is the closer you are to the mic, of course, right? So that helps.
Well, one thing is in this particular room, like a lot of the sound escapes. It's kind of pathways between an open ceiling and closed, but like you have a lot of the sound escape. If you had a full ceiling, the sound would reflect within the space more, so you get more sort of even coverage due to reverberance, like even pickup, even listening to it as well. So it's a very unique kind of space.
Are the microphones used for voice lift also capable of simultaneously doing camera direction?
Yeah.
Yes, it's understood. It's understood that that can happen.
We don't need a separate microphone system for camera direction?
No, we use the beam forming microphones to kind of basically find out which of the active mics is the current talker under, and then use that to cue the camera for the recalling the particular preset of a given area. So it's mostly tied to like an exclusive logic of if like there are 10 mics, which of the mics is actually currently active. So
Okay, so this is a different technology than the old presenter lift?
it's related because even on the other ones we sort of, and this one also, we first cue the particular zone and then let the AI in the camera to kind of use the rest of the logic to figure out who is among the talkers. For example, I'm like shaking my hand, moving my lips, so it kind of is smart enough to like figure out, oh, that's like the person between like three people who is talking.
Okay, I think that's fantastic. I think I was just used to the old style of presenter lift where you needed a separate microphone to do camera tracking that was distinct from the microphones that were picking up the presenters.
Yeah, interestingly, some of the camera vendors are coming out with some basic technology where they can trilaterate and triangulate, which is the talker. They specifically say don't use that feed for the audio, like to use it for far in. They just use it for triangulating the talker. So that's like something that even camera vendors have realized, like with basic sort of audio trilateration, you can actually get to a decent enough sort of locational information for the talker and then do the rest with image processing.
Awesome. Super cool.
Is this system focused on one voice at a time, or can you have multiple people talking?
Oh, you can do back and forth for now, because in terms of gain before feedback, it's known that as soon as you start opening more and more mics, feedback builds up and it brings out like the overall level. So we have like ESP logic, which basically governs who are the active talkers here. So we kind of do like depending on what kind of scenario you're running. If you're like in a higher education setup, then you kind of mostly are doing one or two open mics at the most, because usually a talker is mostly the presenter or the teacher. If you go to like a slightly more open sort of the public meeting space, we kind of allow three or four, about three. Sometimes we even don't allow we don't keep a cap on the norm of the mics, a number of open mics. We say like, oh yeah, it can be any to any at certain situation. But that depends really on the acoustics also. It's like a multi-pronged optimization.
Well, you can end up with, for instance, two conversations. You don't necessarily want to hear that conversation.
Yeah, absolutely. Exactly. Yeah, it's like which conversations. If you're having like a side conversation with like, I didn't really get that idea. You don't want to like say that to the audience, but yeah, that's something that we have built that into recallable presets. So technically, if I am presenting, I'm like in a mode where like I kind of talk through my presentation, and then there will be a point where you might have seen in some situations there will be a two mic scenario where people queue up for questioning the presenter. But in this case, you can like have just unlock a preset and then have anyone question as long as they're like coordinated in terms of.
In its actual application, is it more of a number of open beams rather than number of open microphones?
We sort of have a mixer inside the microphone too. So it sort of is intelligent enough to pick which is the most active beam here. We're seeing the most intensity across.
I'm looking at this camera sitting on top of this rack and it seems to be following something around. Is that connected to the system to do that?
We threw that up today. It's actually using visual, so it was
Yeah,
actually
it's only
trained on Denny's outline, I think.
Oh,
Yeah,
Following-
anyone who is wearing a red, it will follow the red. Follow the red rabbit over us.
And Sam didn't introduce himself. Sam is actually the systems engineer. Systems engineer and DSP team member really leading this project, and we just publicly released it in November. So that's the first portion. We're about to release another add-on, which is the any-to-any push lift in April. And it's a project that we continue to investigate and learn more about and develop better. So if you have questions, contact us, obviously at Biamp. But thanks for the time, and we'll definitely hand it off to Scott.
Yay. Thanks, Chris. Hi, Scott.
Hi, I'm Scott. I'm the AV Experience Manager for Biamp. I'm gonna make sure that all of our internal conference rooms are up to date and operating correctly, as well as our experience centers. So we're in the Gemini Experience Center, and we've got demo stations dedicated to our different solutions. This one is our QTX, which is our networked sound masking, background music, and paging system. I'll turn it on and you'll hear it abruptly, which is something you don't want to do when you're installing sound masking. You usually want to have it start low if it's occupied, because there it can be off-putting to suddenly hear this noise. Yeah, the noise canceling might be cutting that out. These are the emitters, the active emitters for the system. You can run about 60 of these for each run. Daisy chain Cat 5. All attached to a single amplifier. And what's great about these is you can do paging to them, as well as sound masking, as well as background music. Kind of a triple threat.
Is the masking sound on now?
I just turned it back on. I don't know.
We don't hear it at all.
We in the room do.
Yeah, it's probably Zoom doing its job.
If you have a Zoom control, you can probably turn off noise reduction and make it.
Is it like white noise or what is it?
It's a proprietary blend of noise.
Yeah.
So yes.
It's not the ocean or it's not the ocean or something like that.
You could if you wanted to. You could certainly add it as forest noise, bird calls.
Oh, really?
Whatever you want to do. Yeah. Yeah.
Okay.
Are you putting in biophilic elements to the masking system these days?
That's a level of detail I don't know.
Okay.
But if you want to submit your question,
Stay tuned.
we can find out.
Okay.
This is a Vocia. This is our more industrial strength paging system. You can do multi-universe or a single universe. So if you wanted to do paging over CobraNet or IP, you could do that to different locations. What's nice about this, it's very user-friendly for office staff or whoever they want to create or give pre-saved notifications and create GUIs for them.
Sarah Smith, please call the operator.
This also has paging and in plenum speakers, fire, Chicago boxes, all that good stuff. And this is our Tessera Lux and Server IO DSP demo station, as well as our control products. This is the Primo and Imperial line. This is the Touch 8i. It's a single IP-based controller, as well as other touch screens that have their controllers externally. What you're seeing colorfully on the screen is our video encoding and decoding boxes, and basically you can take a 4K signal and run it over a 1 gig network or a 10 gig network. You can control the compression ratio if you have multiple devices to kind of maximize how much bandwidth you have. It's great for video distribution.
And the displays you're showing are intended to challenge that coding.
Yeah, exactly. Exactly. Okay. So the image on the right is the source file, the 4K source file.
Those are
We're gonna
results.
pull this monitor out and get a matching one, but this is the output.
Okay.
And I pulled up the software, we could look at the compression ratios and change it and see if we see a difference.
It looks like we're looking at a little maybe latency because of the encoding or whatever, or.
Yeah.
Yeah.
A little bit. A lot of processing.
Okay.
So at Biamp, we are very well known for our DSPs, but also our conference room solutions. This is our bundles station. What I mean by a bundle is basically you get a speakers, microphone, and a DSP package put together based on your room size and requirements. You've got a great calculator online. You can go on and create your conference room virtually, and it'll kick out a bill of material, which could include a ceiling microphone,
Which is the white thing there.
white thing on the top, the colored LEDs, or a tabletop microphone. These come in white or black. These are all networked devices, so the microphone has a encoder as well as the ceiling microphones. What's great about this device is also it provides PoE for your PoE for your microphones, but also power for your speakers. So
Can I ask you, the ceiling tiles that Luke is panning up to periodically, those all look like they're clear plastic?
yeah, what we're showing here is the ease of the cabling. Everything's on Cat5. It's basically a big loop, which is a big time saver for integrators. One type of cable.
Very clean. Thank you.
I'm curious about the Ethernet switches or whatever. I go through this procedure, configure the Ethernet switch, and I see stuff in there that goes back to the telephone company, of course.
Right.
But
What's great about these systems, I don't have any way of demonstrating it at the moment, but what's called launch.
Okay.
So once your integrator's connected, everything according to the chart, which is pretty easy to follow, there's a launch button on our DSP. You just press it, hold it. You'll be guided through a audio series of events to measure the room reverberance, the noise floor, and then adjust the microphones to more or less improve the audio quality on the far end. Yeah. Cool. Got a lot of smart folks down there to do that more.
I use a lot of Ravenna. I mean, there's Dante out there, and several others.
AVB.
What?
This is AVB.
AVB. Okay.
Yeah, AVB.
AVB. Yeah. Okay. Just
lots of flavors.
all the flavors. Yes.
Lastly, to my left here, this is our BYON station, which is bring your own meeting. The concept behind this and the solution is we all have different types of meetings that we hold: Google Meet, Zoom, Teams. You can have an integrated solution in the room where you walk in, it's a Teams room, and then you're kind of stuck. If you bring in your laptop to a BYON room, you can plug into our MPX system over USB-C, cast your video onto the screen over the cable, but you also have access to USB peripherals connected. So this the camera right here, this is our VBC 2800 video conferencing bar. It's got a 50 megapixel 4K camera on it, speakers, microphones, all built in one. So I connect to it, and then I host my meeting on my laptop, and everybody can see and hear. Yeah. Lastly, on the far end of the table, scheduling. We required a company called Evoco out of Sweden. I guess it's been a year and a half, or almost 2 years. The device on the right, the square green, is a cloud-based solution, and the more circular beveled edges is the on-prem version. This basically does tracking of your meeting room, how much usage it's getting. You can report issues with equipment. And it's all tied into Workplace, which is an online cloud platform that we use to manage our devices, conference rooms. And we're just adding more and more features as we go.
Cool. Questions? Nice.
All right. Thank you.
Thank you.
Yeah. Pass you over to Todd.
Hey y'all, I'm Todd Stevens. You'll be hearing a little bit more from me later on, but I'm the director of the Loudspeaker Solutions Group. So this is all my world, and amplifiers, which are in that cabinet right there. But this is a self-serve demo wall. So it's the same kind of thing we use at trade shows, but feel free to listen, select speakers. We won't spend time really listening to things here right now, just in the interest of time. But this exemplifies kind of the vast world we have, because we have over 200 particular SKUs with over 400 variations. So lots of speakers, and we're just not going to be able to deploy them all. But everything like our I-Series, high performance, wood boxes here, big 12-inch, 15-inch two ways, 15-inch three ways, all smattering of subwoofer options in this. And then you also have outdoor versions. If people know the name Community, it's usually associated with outdoor. So we do that very well. So lots in that family, down to more of a budget-friendly V series that have been around. So we see a lot of both of these, but you can imagine like House of Worship World or restaurant, retail, hospitality. They like to play in that realm, but high performance as well. To our ENT, our DeSono Entasis column line source or column point source, which is point source in a column format. More in our DeSono category. So we have different product families. So, community boxes and then DeSono elements here. Small to large surface mount with really cool mounting. I geek out about the stuff that makes installers happy, but these little click mounts that actually capture all your wiring while you're on the wall. It captures it right in these Wago connectors. And once everybody else is done messing with the room, you come in and just click the speaker on it, makes final contact.
Okay.
Yeah, so cool things like that.
Looks like it's by-wired.
Yeah. Daisy chain multiples. But also all weather performance out of these things. So we build products that'll kind of just go anywhere. Ceiling speakers, lots of those. Kind of a couple different families. Whether you need stuff with soft domes, kind of, just again, kind of restaurant, retail, hospitality, lush kind of sound. But we also make ceiling speakers with compression drivers. Works really well in high noise environments. Get that speech intelligibility, because we care about speech intelligibility in all of our products. R series, if you drive around any city, you'll see those on all the ball fields. We use those in convention centers. This is just a small collection of all the R series available. That's the smallest one, but we go up to our big like R2s, the big R2D2 looking things.
Okay.
And one of the newest products kind of falls in line with what we're doing with LVH today in terms of the asymmetric patterns. This is called our CCA 80 or constant coverage aisle speaker. It's a enormous vertical in terms of warehousing, distribution, large format, grocery stores, anything like that, where you have terrible acoustic environments. So I need to start governing what I'm shoving around that environment. I need tight pattern control, but I also need it to go long distances so I can minimize the amount of devices that I'm deploying in those places, because lots of sources, you get lots of time arrival issues. And so we want to manage that acoustic impact of deploying traditional speakers and not your horns. We have inexpensive horns. There's a time and place for them, but they do not equate to intelligibility. So this is the three-way amplitude shaded device. So the top of the pattern, very narrow, and you can start calling things like 30 degree or something. Doesn't really matter. The point is, I want long distance, long throw, and then wider under the speaker, amplitude shaded, so it's nice and even. So I'm getting into that like 3-4 to 1 D1 D2 ratio. I can cover lots of ground from a single device makes install a lot easier, fewer devices, all that fun stuff. So that's going to kind of carry our conversations in terms of pattern control, and of course what we're doing with LVH that we're going to spend some time. So it's a utilitarian kind of device, but it matters when it comes to intelligibility, because a lot of employee satisfaction, and just think Amazon workers, the turnover there is like 300%. There's just no happiness, right? So you give them music, they want, something to keep their experience good, but also just the longevity of sitting in a place with loud noises. If you have to hear something, your ears start going. So keeping the intelligibility aspect alive is very critical. So you can do cheap stuff, lots of horns, might not be the right solution. Use fewer of these. Now you've got BGM and paging capabilities. That's a really quick look at some of our speakers.
Cool. All right. And with that, the tour is concluding. Oops, sorry, I kicked the camera. We're going to go back into the room. We'll have an intermission here. Jess, do we still want to keep a intermission now at, I guess, 18 minutes and then have the formal presentation start at 5:30?
That sounds great. Yes, that gives everybody a chance to get some food. We may have some more folks joining after work. I see a few emails of looking for links. So yeah, this sounds great. Thank you so
Excellent.
much.
All right, I'm going to mute this iPad and we're going to walk back in the room, and we'll be back in hybrid mode in about 18 minutes.
All right, sounds great.
Thank you.
Thanks, Luke.